All right, let's dive into this explainer and completely demystify angles. We're taking them right off the dusty chalkboard and placing them firmly into the real world. A lot of times, we kind of think of geometry as something just stuck in math textbooks, right? But the truth is, the exact degree of a corner literally shapes absolutely everything around us. Seriously, have you ever actually noticed the invisible corners shaping our world? Because when we talk about angles, we aren't just talking about arbitrary numbers you have to memorize for some test. No, we're looking at the fundamental building blocks of our entire universe. Whether you're chopping vegetables in the kitchen, just pushing open a door, or watching a plane fly overhead, angles are dictating the movement and the very structure of your reality. Just take a look at how angles power our modern lives. It's kind of mind-blowing. In architecture, think about the striking sloped roofs of the Sydney Opera House. Those specific angles are absolutely crucial for structural strength. Or pull out your phone. Your GPS uses satellites that pinpoint your exact location by measuring precise angles. It doesn't stop there. Mechanical engineers use them to angle bicycle gears to transfer your energy smoothly. Even art, Van Gogh's energetic brushstrokes create visual depth using angles. And in robotics, perfect angles are what allow those massive mechanical arms to do precision welding and assembly. They are everywhere. Section 1, Anatomy and Naming Rules. Let's break down what an angle actually is. Okay, the absolute crucial starting point here is the vertex. Whenever you have two lines or rays meeting up at a common endpoint, that corner they form, that intersection is your vertex. It's basically the cornerstone of every single angle you will ever measure. And extending right out from that vertex are the arms. Since these arms are rays, they start at the vertex, and theoretically, they just go on forever in one direction. So the angle itself, that just measures the amount of turn or the space between those two arms. It tells us exactly how far apart they've spread from each other. Now, if you want to name these angles like a pro, there's a pretty straightforward logic to it. Usually you'll use 3 points, but the golden rule is that the vertex letter is always securely in the middle, like angle ABC, where B is the vertex. You can also just use a single letter for the vertex if there's no chance of getting confused, or even a number if there's one written right inside the angle. Oh, and always remember to pop that little angle symbol right before the name. Moving on to Section 2, the angle bestiary. Let's categorize these things by size. Notice how an acute angle kind of looks like a really sharp letter V. That's because acute angles measure less than 90 degrees. This is a perfect contrast to an obtuse angle, which looks a lot more like a wide open door. Obtuse angles are greater than 90 degrees, but they don't quite push all the way to a flat 180 degrees. But, the really interesting category here is the reflex angle. For this one, we're looking at a rotation that's actually greater than 180 degrees, but still less than a full 360-degree circle. It's essentially measuring the outside rotation of a bend. Imagine looking at a clock face, or even picture someone's limbs bent backward in one of those extreme yoga poses. That space on the outside, that's what you're visualizing when you think of a reflex angle.
All right, Section 3, Measuring Angles Like a Pro. Spotting an angle is one thing, but to build a bridge or program a robot, we actually need to measure them accurately. Grab your trusty protractor. It's just a simple 3-step alignment. First, anchor the bottom middle of the protractor right on your vertex. Second, line up the horizontal line perfectly with one of the rays. And third, start at 0 and just follow the curve to read the numbers where the second ray lands. Boom, you've got your exact degree reading.
Now, what happens if you run into a reflex angle? Protractors usually max out at a flat 180 degrees. Well, don't panic. It's super easy. Step 1, you just measure that straight 180-degree line. Step 2, tilt your protractor to measure whatever's left over. Then step 3, just add those two numbers together. So 180 degrees plus, say, 30 degrees gives you a 210-degree reflex angle. Simple as that. Section 4, Dynamic Duos. Let's look at angle pairs. Sometimes angles like to work together as a team. Putting them head-to-head, we've got complementary versus supplementary angles. Complementary angles are two angles that add up to exactly 90 degrees, forming a perfect square corner or right angle. Supplementary angles, on the other hand, sum up to exactly 180 degrees. Put those two together, and they flatten out completely into a straight line. And finally, Section 5, the 360-degree mystery. So, we've reached the grand finale. Why on earth is a full circle exactly 360 degrees? Think about it. We use a base 10 system for almost everything else in our everyday lives. It just makes sense, right?
So why don't we divide a circle into a nice, simple, round number like 100 degrees?
Well, believe it or not, 100 would actually be a terrible system for circles. 360 is what mathematicians call a highly composite number. If we used 100, it only divides cleanly by 9 numbers. Try dividing 100 by 3 and you get messy, repeating decimals like 33.333, yuck. But 360, it divides perfectly into 24 different whole numbers. Halves, thirds, quarters, fifths, sixths. It makes performing common geometry calculations beautifully simple and totally free of those messy decimals. To really understand where this brilliant number came from, we have to take a quick journey back into ancient history. While we rely heavily on a base 10 decimal system today, ancient Mesopotamians, like the Sumerians and the Babylonians, they used a sexagesimal system. Now, that's just a fancy word for a base 60 numeral system. They actually had 60 different symbols for numbers. And that ancient system is exactly what heavily influenced how we still measure time and, yep, how we measure circles today.
You might be wondering, how did they easily count all the way to 60 without a calculator? Seriously, try this at home. Look at your right hand and use your thumb to count the 3 knuckles on your 4 fingers. 3 knuckles times 4 fingers, that's 12, right? Now raise 1 finger on your left hand to mark that you've completed 1 full set of 12. If you repeat this entire process for all 5 fingers on your left hand, 12 knuckles times 5 fingers equals exactly 60. You can literally count to 60 using just the hands right in front of you. It's genius.
And this elegantly builds right to our big conclusion. If you draw an equilateral triangle besides equal to a circle's radius, you can fit exactly 6 of those perfect triangles inside a circle. Since the Babylonians used their base 60 system, they assigned each of those triangles a base value of 60. So take those 6 triangles, multiply them by 60, and it perfectly fills a circle, giving us our magical 360 degrees. Mystery solved. So I'll leave you with this. As you look around at the architecture, the art, and the technology shaping your everyday life, how will you view the invisible angles hidden in plain sight? The next time you swing open a door, navigate across town with your GPS, or even just check the hands of a clock, remember, you aren't just looking at random shapes. You're interacting with a highly refined mathematical tool. It's literally a language of the universe that has been actively evolving for thousands of years.